let's start this. We've got a series of basically sessions on Drut technology, and this is our first. It's going to be great fun. We've got a lot of really good subjects. We want them to be fairly short and snappy, live technology type stuff. So limit the marketing if we can. And this session today, I'm actually going to do a data center server dynamic attachment demo, and this will lead us down a lot of paths, a lot of interesting questions. I think we'll answer some of these questions here. We may have to do additional sessions for more deep dives. This session will be complete. I'm going to make it do something real and exciting, I hope, but it's also a bit of a teaser, I think, because it'll probably you'll see the possibilities of where you can go with it. Now, one thing about this is really there's the what and the why is probably critical for something like this. You know, what are we going to show you and why am I showing you this? The what is really, you want to take a resource unit, PCIe device, and I want to dynamically attach it to a data center server, right? So I've got GPUs, storage devices, network devices, anything that's got a PCIe slot attached to a server. I want to dynamically do it through the Drut technology. And so why on earth do you want to do that? Well, there's a lot of use cases and possibilities, particularly depending on the type of device that it is. And I think we're going to do a lot of sessions where we delve into some of these use cases. I think as you think about it, you'll see they expand, they get really interesting, the different ones. But the core why is you imagine how data center operators purchase their servers today. They don't really know often what they're using them for, and they don't really know the resources they need. So you tend to overbuild it or underbuild it sometimes, which is bad because then you don't have enough resources. But you often get it wrong. You don't have the right resources in the right place. You don't have enough GPUs. You have too many GPUs in this place and not enough over there. And then you get frustrated users and you get a waste of resources as well. So it's costly, it's wasteful. There's a lot of problems. And I haven't even mentioned power. You know, the power draw from GPUs, for example, is huge. And there's a whole bunch of use cases to make this really interesting, the technology that I'm going to show in this demo. So my name's Simon McCormack, if you don't know me. Hopefully everybody knows me. Product management is what I do at Drut. I've been in the industry for a couple of years now. I think my first networking job was 1986. So there we go. How about that one? X25 networks. I've been in Drut for a few months now. I'm very excited about the opportunity we have. So I want to start off, I'm going to zoom through this pretty quick because we want to make this less than 30 minutes if we can. I want to talk the 5 elements that are key to this solution: 3 hardware and 2 software. The FIC 1000. So this is the core intellectual property we have that is a server-based PCIe module. You plug it into a server. Pretty much any server that will take a PCIe module, and pretty much any server can take a PCIe module. I mean, that's how the technology works. We've got a server, the FIC module plug into the server. Now, the what are we doing is we're trying to create the resources. So we've got a resource unit, thing we call the Pro. The resource unit has the resources being GPUs, network cards, storage devices, smart NICs. There's an endless list of possibilities of resources you can add. GPU is the exciting one now. Everybody talks about because there's a big use case for that. But the others have a very interesting use case as well. They each have their own individual use cases. And I'm going to show you a little diagram in a moment that shows the picture of the demo that I'm going to do as well. Then I'll have these elements in it. The photonic fabric is the glue that really kind of glues the servers to the resources. So we want to do it dynamically, gracefully, and easily for you, and allow it to scale. So we built it in a photonic fabric layer 1 connectivity between the servers and the resources. The beauty of that solution actually makes it very simple at the base level, very standards-based and very simple, very interesting technology. And I'll show you a little bit more about that. Now, the glue, not really the glue, the thing that makes it possible, because there's a lot of hardware in this, sounds a little bit complicated if you look at pure hardware level, but actually there are the possibilities here of a lot of software elements that can make this solution really sing. So we've got 2 key elements: Fabric Manager. The Fabric Manager software is the piece that will program this for you, and that's what I'm going to demonstrate a lot. It's a very low-level fabric management type configuration. We've also got our software platform. So we discovered very early on in the life of Drut is that you've got to get involved in the software stacks of the servers to make this possible. We built layers of software stacks. You see in the bottom right-hand corner, my little triangle. So the infrastructure hardware layer we built into the DSP, and then we took it up the stack to hypervisors, to the workloads, and ultimately your AI type workload solution that you want. The reason that became really important is it's part of the solution. If you do it separately, it becomes a little bit harder. So we built this software together. I'm not going to talk much about that today, but it's a very exciting future for us. I think we'll do a webinar just on the DSP. You'll see bits of it today in the demo. Moving into my diagram, because I'm trying to make this fairly quick. I've got a bit of a diagram here, and I'm going to zoom in and make it simpler. So actually, it's not too bad, this picture, right? I hope you think so. I'm going to make it simpler. That block in the top left corner, management and networking, I'm going to cut it out because management and networking is needed for obviously the management and the connectivity. None of that is changed in the Drut fabric. It's still the same. So you'd use your existing networking constructs as you would before if you want to do server-to-server communication. But what you'll see in some of the use cases of the Drut technology, actually, sometimes you don't quite need as much networking as you did before because we can attach these resources dynamically out of band of the network and reduces the need for networking, I think, which adds a lot of possibilities and value in those solutions. So now I've zoomed in a bit and I've got two servers on the left. Okay, those are just regular servers. There's a Supermicro server and a Dell server there, just standard servers, nothing special about them. They can take a PCIe card like any server can. On the right-hand side, there's two resource units, and you see I've got some NVMe drives and a NIC card, and those resource units have actually GPUs and a bunch of other stuff as well, but I'm trying to simplify and focus for the demo. There's a whole bunch of them devices that are connected in them. Okay, and then there's the optical switch in the middle. Now, the reason I just want to show this one, obviously, it scales the left and right scales. I have lots of servers, I have lots of prues, I have lots of optical switches if I want to. So it scales out, but from the perspective of a single server, I zoom in another level further. So this is one server. This is a really important point about this solution. You can build big networks. As you build out and scale out, big networks become really complicated. You know, there's a many-to-many scale type problem. This solution, from the perspective of a server, looks like this. So this server doesn't care that you've got the other resources from any other solutions. It becomes a very, very simple point-to-point connection. So I'll describe what we have. The server here, CPU memory, boot disks, as usual, bunch of network cards. On the right-hand side, you see the FIC1000. And I've cabled the FIC1000 into the optical switch. That's just two cables, plug them in anywhere, and it'll discover where you plug them in. So cabling is very simple. So from my server, I just connect. In this case, I just use two. You can use a varying amount of cables. The optical switch, in this case, I've connected two cables into my resource unit. Okay, and if you go back to the previous one, you see I had to the other resource unit as well, etc. But this is the view of this, how it can get the storage devices connected. The cabling becomes very simple. Now, the bit I was talking about, to the simplification of it, how does this work? We've essentially extended PCIe bus from the server to the resource unit. What does the server think about that? I'm going to show you in the demo. The server thinks that you plugged a PCIe device into it. So it's like you've just plugged a PCIe device into it. It doesn't know that there's this optical fabric behind it because it's all seamless to that. That's really important. I don't want to have to make a big vendor integration effort to make this work. I'm going to make it work with any standard server, which is pretty critical ultimately for the solution. So when I connect it with our software, it looks a little bit like this. My PCI bus is just extended, and that's a core technology. Drut's technology here of what we've built is the ability to do this. So this is our core intellectual property built into the solution. But what it looks like from the server's point of view is I've just extended the bus, and here's a resource for me, and I can do it on the fly and change it. As I'm going to do in my demo in a minute. Well, actually, let me do it right now, I think. I can go to my demo, because there's nothing like a demo to show you what's going on. So I've jumped into my Drut software platform, and I'm showing you, I'm going to spread my thing out a little bit, and I'm showing you our dashboard. So this is like resources and blocks, kind of an admin dashboard, let's call it. I'm going to zoom very quickly into nodes. Now, I talked about a couple of software pieces, right? I said Fabric Manager and software platform. That's kind of an architectural thing. Let me zoom into this super micro server that I've got here. So if you look at this screen here, we've discovered the cores, their Intel, Gold CPU, memory, the storage in that server. So we have knowledge at the low-level IPMI of this server so that we can control it. And that's built in, that's DSP software is doing that. A lot of open source capabilities built into this. Okay, and this is our Supermicro Sys110P product. Now, I'm going to jump back to that screen I showed you before, the Fabric dashboard. So you see this screen, it says it's Fabric Manager is running at this screen. This is actually a Fabric Manager screen. So in the same UI, I've really done a context switch, integrated single sign-on between two products. That lends itself to a lot of possibilities for the future to build more stacks into it. I'll show a little hint here. I go to Monitor, Ceph, and Kubernetes. I'm not going to say any more about that than that, but you can see the possibilities, single dashboard that is layered on the stacks. The software alone in this technology, we think will be very interesting to a lot of customers. But now I'm here, I'm showing Fabric Manager pieces, and I'm going to go into my nodes view, and I've got node 1 and 2. Those are two servers that I was looking at earlier. I'm going to go into node 1. So this is a screen where I've composed a node previously. I think in a session in the future, we'll do the Drut node composition webinar, where I'll actually compose a node from scratch, which will be an interesting thing. Today, I'm just attaching the resources. So I go to my resource block view. I don't have any resources. Now I'm going to bring in, I'm going to bring in another screen because I want to show you what the server thinks about this. There's my Gmail behind. I'm going to kill that. We don't care about my emails. So I've logged into the Supermicro. It's here. I'll zoom in one level on that. I'm going to go move him up. I'm going to take this screen and move him down so I can show both together. It's going to be great when I get this right. So this is the server itself. So this is, I've SSH and logged into a server, into the standard Supermicro server. So what does he think? He has there's a command called lspci. It's the raw PCI bus commands that you can get. But we do that, type grep Drut. You'll see there's a Drut PCIe bridge in there. That's the FIC card that got plugged into it. The server doesn't really know what to do with it, but it knows it's a PCIe bridge. Right, it recognizes it. Don't have to do anything special for it to recognize it because it just uses those standards. I'm actually going to watch this. Screen, and you'll see it's just going to monitor. Because when I attach it, we'll see what happens. So I'm on node 1, which is the Supermicro. I'm going to take action, and I want to add a resource. Now I've got a bunch of options here. Offloads GPUs. I'm not going to do that today because I want to do GPUs in another session. GPUs will be an exciting session in the coming weeks when we'll do that, because there's a lot you want to do with GPUs. For today, I'm just doing networking and storage. So you see I've got a network option, and when I bring it up, I can see I've actually got an Intel gigabit Ethernet device that's in that module. So I can attach the network device. Let's say when I talk about the use cases, and it lends itself, goes in many directions, the use cases, adding an Ethernet NIC on demand to a server is interesting in a lot of secure type places. Imagine you've got a server that's not connected to a specific network. On demand, I can attach it to that network. It simplifies a lot of problems. Lots of interesting use cases with this technology. Anyway, let me just attach it. We'll see what happens. So I attached it, said make it work, make it be part of that server. Now, if you look at the screen above, I'll zoom into it. You see, actually, so it's discussed. This is the server itself telling me, oh, I've got an Intel NIC now. And it's also discovered another Drut bridge. Basically, that's the FIC card in the resource unit. So it's discovered both of those. As far as the server is concerned, someone's just plugged a PCIe device into that server, and it's as happy as can be. Now, what a server does when it receives a new PCI is OS dependent. So some OSs not really happy if you just plug a new PCIe device in. Or they're not unhappy, they're more like they might require a reboot sometimes. We've actually got some kernel patches to allow this to happen. So we've got some pretty unique technology to allow that dynamic attach. Let me remove it. This gets more fun. I'll remove it, take action, detach it, make it go away. This is what you want to do is on add, attach, move. I've removed it. And let me go to my other server. So this is a Dell server now. So my node 2, go back here, fabric, nodes. My node 2 is a Dell server. I'm going to run the same command here, this watch command. He's got a fit card, and I'm going to resource block, attach the same network card. So one of the things that's striking to me about this, the speed of the operation. You say at this scale where it's specifically determined and attached to a single server, it's super quick and instantaneous, making it possibilities for you to do automations. That's one critical thing. I was saying, Bill, earlier. Remind me to mention APIs. The UI you see is fully API-driven UI. So often I use the UI. We're really demonstrating the technology, but we expect higher level applications to do API provisioning. So you fully automate this. So you imagine you've got a situation where you've got a user that just needs, he's going to come to you and say, I need this much CPU, memory, GPU resources. He doesn't care what you've got in your infrastructure. He just knows what he wants. So to be able to automate that and build it on demand is incredibly powerful for a lot of customers. So that's really where you build it into their workload in automation tools and make it automate this for them. So I attached the network card just like it. So I basically attached it over there to the Supermicro. I removed it and attached it to the Dell. That in itself is kind of mind-boggling technology that you can do that. Now let me add another resource. I'm going to go to the storage. You see my storage list have a bunch of NVMe drives. Yeah, these little drives, and you can, two of them are attached together. But I'm just going to grab the first one and attach him. So again, same thing. We monitor what's going on, and then he's discovered the SanDisk. So I can just continue to add more and more resources to the different servers and automate the entire thing and basically build. I think the one way I like to think of it is, you imagine what I was talking about earlier on, that core use case. The value of being able to do this, you buy lots of servers and you often over provision the servers. In this case, you can buy lots of little servers, make them thinner as a standard build. And then as users want more resources, use this technology to add the resources dynamically to the solution to be able to build a data center the way you want to build it rather than the way you built it because you weren't sure what was going on. So that's the core pieces of the demo. I'm just going to reiterate the value. Actually, I'm going to tell you one more thing is that future-wise, see on this hardware machine section, there's a very interesting demo I want to do on that in the future where we bring a machine in the first time and then we ultimately compose nodes. So we say node, compose it, and we compose those nodes into the environment. I want to do that in a demo. It often brings a lot of questions, but I wanted to summarize that basically what I've shown you today is obviously this dynamic resource attachment where we can on demand with a server running attach any kind of resource to it. What happened behind the scenes you didn't see, it was programming that optical network. I think that's a session we want to do in the future as well. We'll show that programming. But you think about this, I did the demo. You don't have to, as a operator, you don't have to get involved in the programming of the optical network. It's just connecting A to B. It's actually relatively simple in a way, but it's smart software that can do it. That's the session we want to do. But I want to show the operator perspective. They don't need to consider those things when they're actually operating it. Well, I appreciate everyone attending, and we'll see you on the other side.